My dear students, in this video I am going to solve system of linear equations by matrix inversion method. That is, the system of linear equations are given and they ask you to solve the equation by matrix inversion method. Matrix inversion method is nothing but finding the inverse of a matrix. So the same method is also in CBSE syllabus, 12th standard maths. In CBSE 12th standard maths syllabus also the same topic is there. Therefore, this video is more important for both CBSE students and State Board students. See, there are two equations, linear equations given. 2x plus 5y equal to minus 2 and x plus 2y equal to minus 3. These two linear equations, this is 2 by 2 linear equations in two variables, xy only. First, I convert this linear equation into matrix equation. Coefficient of x is 2, y coefficient is 5, 2, 5, x coefficient is 1, y coefficient is 2. So this is 2, 5, 1, 2. Coefficients of xy is considered as a matrix, 2 by 2 matrix, and a column matrix, the variable xy equal to the constants minus 2, minus 3 on the item. This is a matrix equation. See, this matrix is called A matrix, and the variable matrix xy called X matrix, and the constant on the right hand side matrix is divided by B. So Ax equal to B. Pre-multiplying by A inverse on both sides, you will get A inverse into Ax equal to A inverse into B. This A inverse into A is, identity matrix. I into X is A inverse into B. So I into X is X equal to A inverse into B. After finding the inverse of the matrix A and multiply with the matrix B, you will get the unknown values X and Y, X matrix. This method is called matrix inversion method. You convert the linear equation into matrix equation and find matrix A. Versions of the xy are called A matrix and column matrix xy matrix equal to right hand side column matrix is constants minus 2, minus 3. Now, to find the A inverse, you know the formula for A inverse. A inverse equal to 1 by mod of A into at J. This is your formula. A inverse is 1 by mod A into at J. What is modulus of A? Determinant value of A. You know A. A is 2, 5, 1, 2. 2, 5, 1, 2. So the determinant value of A is determinant of 2, 5, 1, 2. Finding the value, you will get 2 2s are 4. Minus on expansion, you will get 1 into 5, 5. So this is equal to minus 1, which is not equal to 0. So determinant A is not equal to 0, therefore the inverse exists. Mod A should not be 0, then only inverse exists. So the A inverse can be exist because mod of A, determinant of A is not equal to 0. Now what is at J? For kind of considering to find at J, first find cofactors C. Cofactors matrix. Cofactor matrix of matrix A. See, cofactor matrix, the diagonal elements should be interlinked. See, cofactor, first element cofactor is eliminating this row and column. First column will get 2. Similarly, cofactor of 5 is eliminating 5, that is 1. Sign is minus 1. Because A1 true. A11, A12. And the element, first column element is 5. It's also in minus sign. Plus minus plus 2. Cofactor of 2 is 2 existing column, 2 column, element existing column 2. And row should be eliminated, we will get 2. So this is cofactor of A. Cofactors A is just interchanging the principal diagonal element and changing the sign. Oh, this element 5, cofactor. After that, you interchange the sign. See the element, this is called A11, A12, A21, A22. The elements of A are denoted by A11, A12, A21, A22. Cofactor is Cij is equal to minus 1 power I plus j into Mij, minor. So cofactor of first element A11 is minus 1 power 1 plus 1 is minus 1 power. Cofactor of A11 is minus 1 power 1 plus 1, that is minus 1 power 2, M11. So minor of 2, the element consisting the column 2, first column, first row, you eliminate it, you will get 2. So this is minus 1 power 2 is plus, therefore you will get 2. That's why I am writing 2 here. Similarly, A12 element minus 1 power, cofactor of A12 minus 1 power 1 plus 2. This is minus 1 power odd power is minus M12. This is minus M12. A12 element is the column and row is eliminated. Okay. You will get first column and first row. Second column eliminated, you will get minus 1. Minus this element 1. So you will get minus 1. This is cofactor of that. Similarly, cofactor of A21, cofactor of 1. A21 is also minus 1 power 2 plus 1 is odd power. M21, this is minus 1 containing, eliminating second row first column, you will get 5. Sign is minus 5. 5 minus 5. Okay, and A22 is minus 1 power 2 plus 2 plus M22. So that is equal to minus 1 power 2 plus 2 is plus, eliminating the second column, second row, you will get 2. So like that you have to find out the cofactors of the elements in the given matrix A by using the rule Cij equal to minus 1 power I plus j into Mij. Mij is a corresponding matter. See, after finding the cofactors, you transpose it, you will get the adjoint of the matrix. Next, adjoint of the matrix A you want. For that, see, Aj is 2 minus 1 minus 5 2. Transpose of this cofactor, that is 2 first column becomes first row, 2 minus 5, second column becomes second row, minus 1 2. So this is Aj. Immediately by seeing A, you can find out Aj by replacing the principal element, principal diagonal element 2 2, interchange 2 2. And the secondary diagonal elements you will change sign only, minus 5 minus 1. Minus 5 minus 1. This principal diagonal element is interchanged, 2 becomes 2 here and that 2 becomes 2 here. And the sign of the secondary diagonal, minus 5 minus 1 is there. Therefore this is Aj. After finding Aj, we can immediately say A inverse is 1 by mod A in Aj. What is 1 by mod A? Mod A is minus 1. Okay. I am correcting here. See, what is A inverse? A inverse is now 1 by mod A. Mod A is minus 1. Mod A is minus 1 into Aj. Aj is 2 minus 5 minus 1 2. Now you multiply with a minus inside. 1 by minus 1 is minus 1. Minus 1 and you bring it to the matrix, you will get minus 2. Minus 5 into minus 1 plus 5. Minus 1 to minus 1 plus 1. And 2 into minus 1 minus 2. So this is your A inverse. So A inverse of the given matrix is -2, 5, 1, -2. This is the inverse of the given matrix A. That's all about the problem using matrix inversion method. Okay. Now after finding the A inverse, we are going to find out the solution for x and y. We will see. Okay. Now after finding A inverse, we are going to replace this into the matrix equation x equal to A inverse into B. What is x? The column matrix XY. What is A inverse? -2, 5, 1, -2 into B matrix is -2, -3. So after multiplying the matrices A inverse and B, you will get first row, first column, 2 into -2 plus 4, 5 into -3 -15. First row, first column, 2 to -2 into 2 -2 plus 4 and 5 into -3 -15. Second row, first column, 1 into -2 plus 2 into -2 into -3 plus 6. So this is equal to 15 -15 plus 4 is -11. 6 plus 6 -2 is 4. So that's all about the problem. X equal to -11 and y equal to 4. After finding x equal to -11, y equal to 4, by taking these two values in the first equation, 2 into -11 plus 5 into 2, 5 into 4 equal to 2 into -11 is -22 plus 5 fours are 20. -22 plus 20 is -2. -22 plus 20 is -2, which is on the right hand side, -2. So similarly our value is correct. X equal to -1, y equal to 4. After substituting this equation, we will get -2 on the right hand side. So as to the second equation also you can check. X equal to -1, y equal to 4. 2 4s are 8. -11 plus 8 is -3. Second equation also gets satisfied. Therefore, the solution for this equation is this. This is the matrix inversion method. Okay? Now, I am going to solve next sum consisting of 3 variables, x, y and z. 3 equations in 3 unknowns. See, we are going to solve these 3 equations in 3 unknowns by using matrix inversion method. For that, I am considering this equation into a quotient matrix 2, 3, -1, 1, 1, 1, 3, -1, -1. This is your A matrix. 2, 3, -1, 1, 1, 1, 1, 3, -1, -1 into column matrix X, Y, Z is equal to right hand side column matrix is 9, 9, -1. 9, 9, -1. This is of the form Ax equal to B. From this we want x. X is A inverse into B. We know from this equation A inverse into B. After finding A inverse, you multiply the matrix with B, you will get the unknown x. For that, you first find out the cofactors matrix. Cofactors matrix. That is, cofactors matrix is, I am writing the cofactors matrix here. Cofactors matrix. Considering the matrix A, this is your matrix A. What is A? A is 2, 3, -1, 1, 1, 1, 3, -1, -1. This is your matrix A. So what is determinant A? We have to find out the determinant value of A. That's equal to 2 into 1 into -1, -1. 1 into -1, -1, minus of minus plus 1. -3 into the second row, first column, eliminate 1 into minus 1 is minus 1 and 3 into 1 is minus 3. Minus 1, minus 3 and minus 1 into third column, first row. Eliminating the third column and first row, you get 1 into minus 1 and minus 3 into 1 is minus 3 into 1 is minus 3. That is, this is 2 into 0 minus 3 minus 1 minus 4 minus plus 12. And this is minus 4 into minus plus 4. You will get 16. So determinant value is 16. So after finding this modulus value, this is not determinant value of A is not equal to 0. This is not equal to 0. Therefore, inverse exists. First cofactor of element 2. Eliminating the element 2 containing, you eliminate the row and column, you will get 1, 1, minus 1, minus 1. That is the small minor. Eliminating to 1, 1, minus 1, minus 1. 1, 1, minus 1, minus 1. Similarly, A1, 2, second row, second column, first row, second column element. 3, cofactor of 3 is eliminating second row, second column and first row. This is 1, 1, 3 minus 3. 1, 1, 3 minus 3. Sorry, 1, 1, 1, 3 minus 1. This cofactor becomes minus because you know first element cofactor is plus, it is minus, and the next one is plus. Next cofactor of the minus 1 element is in plus notation because we know this is A11 plus A12 minus 1 power 1 plus 2 minus, I already told for finding the cofactor, and this is A23, A11, A12, A13 minus 1 power 1 plus 3 is positive, minus 1 power odd, even power, therefore it becomes plus. So after see, for finding the cofactors, here this element cofactor of 2 is plus, cofactor of 3 is minus, cofactor of minus 1 is plus, this is cofactor of 1 becomes sin, second A21, this is minus, A22 plus, A23 minus, A31 plus, A32 minus, A33 plus. So to find the cofactors, these are the symbols for the corresponding cofactors. A11, A22, A33. These elements are positive cofactors, and this is also A13 positive and A31 is also positive. 4 corners and middle are positive minors, and all middle elements cofactors are minus. Using that idea, this is plus minus, and that another cofactor of the one is minus 1 is in plus. Eliminating the column containing minus 1 and row, I will get 1, 1, 3 minus 1. 1, 1, 3 minus 1. Okay, next cofactor of second row first column element, second row first column element is minus. So eliminating the second row and first column, 3 minus 1 minus 1 minus 1. 3 minus 1 minus 1 minus 1. Next cofactor is plus. Cofactor of central A22, second row second column. Eliminating second row second column, you will get 2 minus 1, 3 minus 1. 2 minus 1, 3 minus 1. Good. Next, minus A22, A23. Cofactor is in minus, consisting of the eliminating second row third column. The minor is 2, 3, 3 minus 1. 2, 3, 3 minus 1. Similarly, A31, cofactor of 3, this is in plus sign, eliminating third row and the first column, 3 minus 1, 1, 1. 3 minus 1, 1, 1. Next, minus cofactor of minus 1 is eliminating second column and third row. 2 minus 1, 1, 1. 2 minus 1, 1, 1. And finally, cofactor of A3 element is in plus, eliminating third row, third column, 2, 3, 1, 1. These are the cofactors of the corresponding elements of matrix A. Now, you simplifying, you will get again 1 into 1 minus 1 minus 1 minus of minus plus 1, again minus of minus 3 minus 1 into 1 minus 1, sorry, 1 into minus 1 is minus 1, minus 1, my 3 into minus 1 is minus 3. Similarly, next cofactor 1 into minus 1 is minus 1 and 3 into 1 is minus 3. This is minus of 3 into minus 1 is minus 3 and minus into minus plus 1, expanding minus minus 1. Next 2 into minus 1 minus 2 and minus of minus plus 3, minus 3 into minus plus 3. Again minus of 2 into 1 minus 2 and this is minus 3, these are 9 and this is 3 into 1 3, minus of minus 1 is plus 1 and minus 2 into 1 is 2, 1 into 1 minus 1, expansion minus become plus 1 and finally the element 2 into 1 2, 1 into 3 minus 3. Finding minus. So this is equal to 0, minus of minus plus 4, minus 4, and this is minus of minus plus 4, this is 1, minus 11 into minus plus 11, minus 2 minus 9 minus 11 plus 11, 4, minus 3, minus 1. This is cofactors matrix. 0, 4, 0, 4 minus 4, 4, 1, 11, 4 minus 3 minus 1. This is the cofactors matrix. Transpose of this becomes adjoint of the matrix. Okay. Now, adjoint of A. Adj is transpose of matrix, cofactors matrix. Transpose of this matrix is column becomes row 0, 4, 4. 0, 4, 4. First column become first row. Second column 4, 1 minus 3, second row 4, 1 minus 3. And third column minus 4, 11 minus 1. This is your adjoint matrix. Okay, adjoint again. 0, 4, 4, 4, 1 minus 3, minus 4, 11 minus 1. Now, A inverse equal to 1 by mod A into adj. This is your formula. A in 1 by mod A is 16. Adj is this 0, 4, 4, 4, 1 minus 3, minus 4, 11 minus 1. This is A inverse. So our formula x, what is x? X, y, z. This is your x. Into A inverse is 1 by 16 into 0, 4, 4, 4, 1 minus 3, minus 4, 11 minus 1. Because we have to convert this x equal to A inverse into B. X equal to A inverse into B. X, this is x. This is A inverse into B. What is B? 9, 9 minus 1. Column matrix 9, 9 minus 1. Now you multiply these two matrices on the right hand side. You will compare with the left hand side X matrix. You will get the solution for the unknown X, Y, Z. Okay. Now, X, Y, Z on the left hand side, column matrix. Right hand side 1 by 16 into first row, first column 0 into 9, 0 plus 4, 0 plus 4 into 9, 36 plus 4 into minus 1, minus 4. Second row, first column 4 into 9, 36, 1 into 9 plus 9, minus into minus plus 4, minus 3 into minus 1, minus into minus 1, minus 3. And 36, 9 plus 3. Similarly, third row, first column, minus 4 into 9, minus 36, 11 into 9 plus 99, minus into minus plus 1. So this is equal to 1 by 16 into 36 minus 4 is 32. This is 45, 48. This is 9 plus 100 minus 36 is 64. So you multiply by 1 by 16 with a matrix or divide each element by 16. Bringing 16 into that inside the matrix, you will get 32 by 16 is 2, 48 by 16 is 3, 64 by 16 is 4. The left hand side you have x, y, z. So the values you have x equal to 2, y equal to 3, z equal to 4. So answer is x equal to 2, y equal to 3, z equal to 4. That's all about the solution for this equation. Thereby I conclude this problem and video. Thank you.